All right, so in this video, we're going to take a general look at scalar and vector quantities. So we're not going to delve too much into any specifics, like things like how we add vectors together and stuff like that. We're just going to focus on what the difference is between quantities that are scalars and quantities that are vectors, and what the significance of the difference actually is. So first thing, what do I mean by quantity? Well, I mean something that you can measure. And so as you can see it down here at the bottom, any text you see in purple is, I think, information you should be noting down as we go through. So pause the video if you need to and note that down. Okay, so for this next part, it might be worth grabbing yourself a scrap piece of paper, so something different to your notes. So there are three things that I would like you to write down as much as you can at this point. So do you know any quantities that are scalars? Have you come across that term before? Do you know any quantities that are vectors? Again, maybe you've come across that before, maybe you haven't. And do you know anything about the difference between scalars and vectors? So pause the video and write down those three things now. All right, so now we've got your starting point, and it might be that you don't know the difference between these things and you actually don't know any, and that's fine. You might know some of this stuff already, which is also good. So let's first of all describe what we mean when we say a scalar or a vector. So a scalar is a quantity that can be described using just one number, and that number is called the magnitude. And a vector is a quantity that has to be described using two numbers, and that's magnitude and direction. Now, sometimes vectors are described using more than two numbers, but you need a minimum of two numbers to describe them. So again, you'll notice those are in purple. So if you want to note those down with your notes on what a quantity is, then we can get started on some more stuff. Pause the video if you need to. Okay, so let's have a look at some quantities that you will have met before, or I think you'll have met before, and show you where they fit. So most people at this point will probably have met the idea of mass, temperature, distance, speed, some of these basic concepts in physics. So the ones you meet first in physics are almost always scalar quantities. And the reason being the mass that they work with is considerably simpler. So that is why you tend to meet them the first. But usually by this point, you've also met your first vector quantity. Even if you haven't called it that, you've probably met forces already. So that's usually the first vector quantity we meet. These ones you may or may not have met before, but this is essentially where this video series is going to go. We're looking at like displacement, velocity, acceleration, etc. But don't worry too much if you haven't met those before and have no idea what those are. And the reason you don't meet these at the beginning of your physics journey is vector maths requires a bit more thought and is a bit more complex than scalar maths is, and I'll show you that now. So let's show some examples of what I've said here. So scalars needing one number to describe them, vectors needing two things to describe them. So you see, mass can be described just using 1 kilogram or 500 grams or 20 milligrams. Time can be just 2 hours or 35 seconds. Although the number comes with a unit, it's described just using one number. Now, something like a force, which is a vector, needs two numbers to describe it. So we've got 25 newtons, which is what we call the magnitude of it here. So with our vector, it has a magnitude, and we also get a direction. Now, sometimes that direction will just be described using words, or maybe we do give it a number, giving it as an angle or something along those lines, but it has two things to describe it. It needs a magnitude and a direction. These just have, in here, we just have magnitudes. That's the difference there. So let's see how the maths works a bit differently for scalars and vectors. So let's do some scalar maths first of all, which is incredibly straightforward. So if you have a 200 kilogram sledge and a 50 kilogram person gets on, the total mass is, so you can tell that I'm recording this at Christmas because I'm dealing with sledges and stuff, but there we go. Now, that's fairly simple. The total mass is you just add them together and you get the total mass. Nothing difficult there. And then if 2 hours have passed and then a further 30 minutes passes, the total time that has passed is, well, I'll do this all in minutes, but again, you get the idea that, okay, we had to do some unit conversion, but all we do is we just add those numbers together. There's nothing too complicated there. If you have traveled 800 meters and then you travel 1.2 kilometers, the total distance you have traveled is, again, same idea. Okay, we have to make a conversion, but we're still just adding together our numbers. Scalar maths is simple. Let's have a look at vector maths, and so we can appreciate why it's important we differentiate between scalars and vectors. So what I'm going to do is I'm going to show you a few examples where with forces of 30 newtons and 40 newtons added together. So our first example, we will have them both acting in the same direction. So this is going to look very similar to what we were doing before. So we're calculating what's called the resultant force. So I use the symbol like this. So this is a sigma, which just means sum of. So sum of the forces is just going to be 30 plus 40, which is 70 newtons. So at the moment, it looks like nothing's different. Now let's do this one here. So let's have 40 that way, and let's have 30 that way. So the sum of our forces here is going to be 40 plus minus, I made that look like a divide symbol, minus 30, which just gives us plus 10 newtons there in there. So you can see here, we haven't just added those numbers together. So depending on the scenario, the sum of the forces or the resultant force is actually different. So those are the two simple ones. Let's now show you another one. So let's say we had 40 newtons that way, and we see we have 30 newtons that way. So here, I can't even write a sigma anymore. Let's fix that. So the sum of the forces is actually going to be the square root of 30 squared plus 40 squared. So you might notice this is Pythagoras, and that's actually 50 newtons. And that would actually be in that direction here. So this one was that way, this one was to the right, this one's to the right, this one's going to be sort of like diagonally upwards here. And then we can have another scenario. So we might have, I don't know, 40 newtons acting that way. And we might have 30 newtons acting that way. And that again, I'm not even going to work through that here because I need more information about angles here. But that's most certainly not going to add up to give you 70. So this is the real difference between scalars and vectors. So with a scalar, the maths is incredibly straightforward. You just get one result at the end. Whereas with vectors, depending on the direction of the vectors, when we add them together, we can get completely different results. Even if those forces, in this case, all have the same magnitude, we can get completely different answers in terms of magnitude and direction in terms of what we get when we add them together. And this is why it's important we separate things into scalars and vectors, because we want to be able to model what reality looks like. And to model what reality looks like, we need forces to follow vector rules, and we need scalars to follow scalar rules. So when we have displacements and velocities, we're going to be using these vector rules to add them together. And I'll show you how the actual mechanics behind what I'm doing here in terms of adding vectors together in a later video. But at this stage, I just want you to appreciate what a key difference is between scalars and vectors and actually know essentially how we describe them. So let's finish off addressing that. So we're making sure we're focusing on our key points. So what I'd like you to do is answer two questions. I'd like you to, first of all, tell me what the difference between a vector and a scalar is. And I'd like you to give me some examples of vectors and scalars as well. So pause the video, have a go at doing both of those things. Let's make sure you've taken away the right things from this video. Okay, so in terms of a scalar, let's get rid of bold. Scalar is described using one number, which we call the magnitude. Whereas a vector is described using two numbers, magnitude and direction. Yeah, so that's our fundamental difference between those two things. So some examples. So I'll stick to ones we've come across before. So some scalars like mass, time, temperature, blah, 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 that you can see more if you've from earlier in the video if you want them. Vectors. The one we need to know at this stage is force, but we are going to see some more. So we're going to get displacement, velocity, acceleration, things like that as we go through future videos there. So that's the key thing I want to take away at this stage. And the other thing I'd add in, so when the same magnitude scalars together, you always get the same result when you add the same magnitude vectors together, you get different results depending on the direction of those vectors. So this is, I think, actually the important difference between them, because this tells you why we need there to be scalars and vectors as two separate sets of quantities. This is fine. It tells you what they are, but it doesn't tell you like why we have them. So this is actually, you know, why we have them, because we have these different rules that they follow. So I want to finish off by taking a look at what our notes should be looking like at this stage. And there's not too much, I think, we need to actually take away and commit to our long-term memories here. I think there's three key things. And you can see over here, what we've got is my retrieval cues. So the one thing I want to know is, well, what a quantity is. And the key word in there is that it's something that we measure. We know scalars are described using one number, which is called its magnitude. And we know that vectors require at least two numbers, sometimes we use three for them, which will give you the magnitude and the direction. So essentially what we should be able to do, when you come back to your notes, cover up the right-hand side, and you can use these cues to retrieve this information from your mind. So quantity, oh, that's something that you measure. That's why there's an M. Scalar, it's used is one number to describe it, and that's its magnitude. So that's what we've got there, and that's where we'll finish off with this video.